All right, we are live and good to go. Hello and welcome everyone to the 48th and the last episode of the IT India Digital Conversations for this year. It's not the last episode of the series, but to give you all a quick summary and a flashback of what the year was like, uh, you know that even with the increased use of digital platforms and networks, it was an uphill task managing the safety of our team here in India while continuing to deliver a superior customer experience. We were still able to reach out to thousands through our knowledge outputs and digital events, helping them stay informed and connected. So, over the past year, this year, the local networks of the IIT in India have conducted 103 digital events, which were experienced by over 9,500 people. The IIT India Digital Conversations, that is this series, which are a flagship webinar series, continue to engage with more than 5,000 people through the 18 episodes this year, taking the total tally to 48 episodes, reaching more than 13,000 people across 50 countries, making it a truly global platform. I am Suman Bhaumik, your host for this series, and I lead the events development for the IIT in India. But before we begin our session, like always, please allow me to take a couple of minutes to tell you a little bit about the IIT and our session in hand today. So, the Institution of Engineering and Technology, also known as the IET, is a 150 years old global organization inspiring, informing, and influencing the engineering community to engineer a better world. As a diverse home across engineering and technology, we share knowledge that helps make better sense of the world to solve the challenges that matter. At IET India, we want to grow actionable knowledge, want to solve India centric engineering issues, and want to enhance people's lives using technology and thought leadership to drive innovation. I have a short video here which talks about who we are and what it is to be part of the IIT India family. Just give me a minute while I play the video.
Our world is changing.
Engineering is changing.
Society is changing.
We are changing.
We're here to inspire,
Inform.
Influence.
And change perceptions.
Demonstrating how important engineers and technicians are in our lives.
Championing achievements.
Helping to create new technologies that enable us to thrive.
And inspiring future generations to make a difference.
Together, we discover new concepts by turning theory into practice.
Create solutions to society's biggest challenges.
Share knowledge and expertise through our networks.
Grow by developing new skills and capabilities.
Evolve and adapt for the future.
We are the IET.
Together, we are engineering a better world.
So that was what it is to be part of the IET. You can get more details about what we do and how can you be a part of it by visiting our website. You can also visit our YouTube channel and you will find all our previous events and videos there. So coming to today's topic and the very important episode which is at hand, which is curated by the Smart Cities Working Group of the IET's Future Tech Panel and is presented by Siemens Technology Services. This episode focuses on addressing the urban water challenge and the possible solutions with the digital twin technology. Now, we have been fortunate enough to have with us an August panel comprising of technology and water experts who will be discussing challenges, use cases, business models, economic benefits, and future roadmaps in the Indian context. So without any further ado, let's welcome the experts today. Introducing our first speaker, Veena Srinivasan, who is a senior fellow at the Ashoka Trust for Research in Ecology and Environment, also known as ATREE, where she leads the Center for Social and Environmental Innovation. As a water expert focused on socio-hydrology, Veena's work has always been interdisciplinary. She has a great passion for using science to turn the levers of traditional systems and make scalable solutions possible in the social innovation space. With CSEI, she is leading the mission to transform scientific research into real world impact by designing solutions that simultaneously create livelihoods and conserve the environment. Veena received her PhD from Stanford University and is an alumnus of the Indian Institute of Technology, Bombay. Our second speaker is Dr. Vijay Saibi, also known as Vijay, who heads Water Technology Center, which is the hub of research and development, digital and knowledge management for L&T water and effluent treatment business. He has over 24 years of experience in industrial research, commercialization, digital strategic positioning, and crafting productized services. A chemical engineer by training, Vijay completed his PhD in system identification and control from IIT Bombay. After a few service in academia and a short stint at the National University of Singapore, he joined Automation Group of Global Research Center of GE in Bangalore and later its business wing GE Water Process Technologies. He led the South Asia technology team of GE Water, later the digital products for business globally. After the divestiture of the business, Vijay moved to Swiss Water Technology Solutions as the technical director for digital. He was part of several award-winning digital initiatives for the business before moving to L&T in May 2021. Our third speaker is Sandeep Chakre, a dynamic leader with 20 years of industry experience. Sandeep is passionate for innovation and digitization, strives for contribution in overall industrial transformation towards decentralization and digitalization. He is an expert on IoT-based new products and solutions introduction and development as per local and global market requirements in alignment with regional sales organizations. He is responsible for managing and timely delivery of innovation and digitalization projects and within budget with utmost quality, driving innovation, digitalization, and IoT capabilities and projects across energy management, smart grid, and smart infrastructure domains. Our fourth speaker is Mr. Sushil Kumar, who comes with more than 30 years of experience in telecom and IoT and ICT. He is presently working as a Deputy Director General and heading the Internet of Things division. Prior to this, he served in various parts of the country as a business head, units of districts of around 23 years in Bharat Sanchar Nigam Limited, which is also known as BSNL, and is part of the Department of Telecommunications now. Having vast experience of planning, project implementation, operations, maintenance of fixed line, cellular, and optical fiber networks, is designed and provisioned the telecom networks for various projects related to e-governance, national knowledge network and corporates, and also for Commonwealth Games cycling event that was held in Noida Expressway in 2010, and the Formula One car racing event in Greater Noida in 2011, while working with BSNL Noida. In his current role, he has created framework for finalizing specifications in M2M, IoT domain with multi-stakeholders participation and in sync with global SDOs like ITU, 1M2M, 3GPP, etc. He also chairs TEC Consultative Committee for adoption of 1M2M specifications transposed by TSDSI, resulting the adoption of 1M2M Release 2 as the national standard. And finally, coming to the moderator for this session, Hari Dilip Kumar, who is a senior member of our Smart Cities Working Group and the founder of SolveSustain.com. Hari is a generalist problem solver at heart with a decade of rich and varied experience in sustainability and social impact. He has worked on clean energy, product development and research, off-grid energy access, water industry and agriculture, food security and participatory governance, and more. Some of these projects have been recognized globally for impact and innovation, including twice by the United Nations. Hari co-founded Fluxgen, a sustainable technologies company in Bangalore. He later worked with Microenergy International in Germany on a concept of swarm electrification and further headed research and product development at SolShare, an international joint venture social enterprise creating clean energy marketplaces in rural off-grid areas of Bangladesh. Following this, he researched systems issued at Public Affairs Center, which is a 25 years old not-for-profit think tank focusing on the SDGs in the Indian subcontinent. He now works with a lot of non-profits and startups on a range of sustainable development challenges through Solve Sustain. I'll now request Hari to start the proceedings for today, and I'm sure that this will have an impactful and engaging conversation with a lot of key takeaways for our audiences. Over to you now, Hari.
Awesome. Thank you so much, Suman. The first thing I should say is It's going to have a lot of key takeaways for me as well. So I've got my pen and I'm taking a lot of notes because, as I'm part of the IET's effort to actually design and research this concept around water digital twin in our context. And I've already been in touch with some of these experts. So, if you will, this is a kind of open public domain design process which we're trying to drive with these amazing people who we have on today's discussion. So with that being said, let me get into the questions because we have a bunch of them, and the philosophy behind the questions is just going to be how do we go from problem to solution, right? Like that chain. So let's start with the challenges of water in the urban Indian context. I know that there are a bunch of them in the agricultural context as well, and linkages through the value chains or supply chains. But I'd like to first ask the panel, especially Veena, who is working very closely with communities and impact approaches and so on and so forth. How can you summarize the challenges of the urban water challenge in India, especially given that Niti Aayog, in its own 2018 report, has flagged a crisis of huge proportions of relating to groundwater in more than 20 of our cities.
Thanks for that question, Hari. I think firstly, it's useful to kind of look at the overall big picture numbers. In cities, I think we all recognize are the engines of Indian economy, contributing to a large or the majority of the GDP and most of the jobs and will continue to be so in the next 20 to 50 years. So we already face a problem of many Indian cities facing shortages, especially in dry years. And for most cities are growing so fast that the infrastructure is not able to keep up. And so you have a problem of the city cores having pipe networks, but a lot of the fast growing suburbs around being completely dependent on groundwater, either through wells or tankers, and groundwater depletion becoming a significant problem there. Another set of challenges, of course, is that cities generate a lot of wastewater, and our wastewater infrastructure has also lagged behind growth. And so a lot of the freshwater sources in cities are now severely polluted. And I think all of us have seen city landscapes with these open drains which are full of sewage. So, this sounds like a very grim problem, but on the other hand, it's important to note kind of what's the easy components of this, and which is that cities still comprise only a fraction of the water use of a river basin. It's hard, 10 to 20% of consumptive use in a river basin is urban, which is still relatively small. But the problem is that unlike agriculture, which can kind of allow demand to ebb and wane with the monsoon, so you can have most of the demand happening in the wet season, or you can fallow areas in the dry season and compensate farmers through crop insurance, you can't really shut down water supply to a city. So even though cities have high value for water, and the value of water in a lot of cities is a small component of the goods and services produced, but cities can't really have the option of shutting down water. And so I think the useful thing to say is that cities therefore have the opportunity to actually solve this problem by either managing their wastewater better and managing storage better, which is more of the rainwater harvesting and urban water bodies that we think about. Now, traditionally, we haven't been able to think about this in a holistic way, and I think that's where the challenge of data, and more importantly, having the data feed into decision making and management comes in, and that's what I guess we're here to talk about today.
Absolutely. I mean, so that was really the essential. So you mentioned groundwater was an issue, wastewater is an issue, freshwater is getting polluted, and there's still a big chance of solving these problems given that the concentration in cities, so on and so forth, but they're still taking a small fraction. And you have sort of highlighted, like, I think two very important aspects. One is the integrated aspect of water management, which needs to get de-siloized, and the second is how can data feed into decisions. So let's go from there and deal with this point of data. So keeping the problems which Veena has highlighted in mind, and of course which many of us some of us might have already seen in our previous experience, I'd like to raise the question, do we have enough data? Do we have the right data? Are we collecting the right data through an outcome-oriented approach to create better water outcomes? Who should be collecting this data? How should they be collecting it? And I think, let's start with the data layer. And I would like to direct this question to Vijay Sai, because I think, just by, I think you'd be great to answer this. Over to you.
Yeah, sure, Hari. That brings a very important point, I would say, because data collection is a very important step in the whole digital twin development. And to quote, Peter Drucker, he comes with a very interesting statement. You can't manage what you can't measure. So that's a underlying fact, when it comes to data. And you brought another important point: what data to collect, what data to process, what data to use in terms of achieving this required outcome. And I know I can actually quote another person, George Fuchsel, from IBM, who says that, very interesting statement: garbage in, garbage out. The data what we are collecting has to be very relevant in terms of doing the required predictions. Otherwise, it's not going to serve the purpose. These are very interesting, points to be considered when designing the digital twin, which is the topic today that we are going to talk. Because data essentially is going to load, your digital twin, and the algorithms are going to churn this up. You are talking about the mechanism to collect the data. This is where the whole problem becomes very interesting. When we talk about the cities that we try to, in fact, address the solution to, and then apply the solutions to, that's a vast network that we need to be looking at the population. The network size is quite huge, and then how you need to, in fact, bring in the information that is relevant from the prediction standpoint is also very important here. Where all you are going to put your sensor does matter, because data is important. Doesn't mean that you have the freedom and the flexibility and luxury to put sensors everywhere what you want to capture the information from. So definitely, optimization takes the precedence here. You got to have a mechanism to understand that what is the information that I am going to collect, what is the extent to which the information needs to be collected and processed, and at what nodes or the points in the network that the sensors have to be putting, what sensors have to be putting, and then where the cost versus the information what I'm getting are balanced. So that's a kind of a Pareto optimization that one needs to be looking into. So that's the step which people are looking into, because how much information is required to achieve what the outcome. So that is one thing which people have been studying right now. But at the same time, it's all the more important to understand that all the sensors and the health of the sensors need not be perfect at all point of time. Over time, there will be deterioration, there will be performance degradation, and so on, even for the sensors which we are using to understand the health of equipment. So from that perspective, having the adequate redundancy at certain point is also important. So it's a perfect balance that we got to have, between all these things, where how much of information has to be collected, at what points the informations have to be drawn from, and how we have to have the adequate redundancy in the system in order to get the quality of the data that we intend to use. So that's what I want to say. Going for the distribution network and the water management system that we are talking about, we got to have information on the pressure, we got to have the information on the flow, we got to think about the quality of the water, which is also a very important point, which is, in our context, we are neglecting it often. Of course, the level will be another parameter which we got to sense. So these are the critical parameters which we got to be thinking all the time.
Thank you, Vijay Sai. I think that's very illuminating. So you've raised these two principles around data. One is that you can't manage it unless you measure it, and the other is, if your input is junk, your output is junk in terms of data, no matter how good your computer modeling is. And these are two principles which anybody who's designing a data collection network should keep in mind. I'd just like to also open the floor to this additional question of what are the drivers of this collection of water related data in Indian cities. For example, I believe there are some new regulations from the Central Groundwater Authority, which are saying that all groundwater extraction by industries have to be, metered by these IoT meters going ahead. And this driver seems to be coming from the recognition increasingly that groundwater is a precious resource and should be costed into decision making. So, would any of the panelists have some comments on this to make? Veena?
Sure. I think it's good to kind of distinguish. I mean, or to divide this or classify it into private sector kind of pressures and regulatory pressures. On the regulatory side, as you said, Central Groundwater Board recognizing that groundwater, and particularly for industrial commercial establishments, pollution control boards in cities like Bangalore, for example, are requiring wastewater treatment plants in apartment complexes to monitor and measure their water along with periodic checks. So the pollution control from both sides, and increasingly utilities themselves are under pressure to improve metering for just for better profitability and so on. But on the private sector side, I think it's also worth kind of noting that there are pressures because as groundwater, as people become groundwater dependent and then tanker dependent, the cost of water has gone up so significantly in some of these peri-urban areas that it is valuable in and of itself. And so you're seeing suddenly a rise in a smart metering market in Bangalore, for example, where apartments otherwise begin to fight about how the water bill, which is considerable, should be divvied up, and how smart metering is kind of a solution to that. So I think there are both regulatory and private sector.
This is very interesting. I mean, so you're saying one is from the like a policy towards valuing groundwater, and the true cost of water in cities is starting to flow and become, like mainstream to industry, for example. So they're that's a policy signal. But you're saying market forces are also recognizing that there's a tanker mafia, maybe just like the auto rickshaw mafia, or like, which is controlling demand and supply in cities, right, of water.
It doesn't have to be a mafia, even if it's just a regular tanker market, which is competitive,
Right,
it would
right.
still be an issue. And then, of course, there's corporate stewardship standards also, which is corporate signing up for water positivity standards.
So I understand. I mean, if you're a hospital, for example, extracting water, and you need to maintain water security to keep operations running, then you would be very interested in what the prices of those tankers are seasonally, because that would directly affect your operations, right? If you're a hospital, sucking out 250 kl of water per day, for example. So I think these are great insights, and I would just add that apart from the market forces and the policy, in some countries in the world, there's also started this thing of consumers starting to become more aware of water use. Because I was recently in touch with some folks from the European Union who have designed like an AI powered shower, which will actually use nudge mechanism to tell the consumers how much water they're using. So maybe it's just a matter of time before consumer pressure also starts increasing. So thank you for those insights, Veena. I just want to move on from the question which we addressed previously, which was the data question, now to what happens on top of this data. Like data by itself may not be able to do anything, but can we create models or machine learning or other related things? So I'd like to address this question to Sandeep and Vijay Sai, because I believe you have a lot of insights when it comes to building models and digitalization. What do you do with the data? Can you just explain to us, please?
Yeah. So Hari, basically, even if you have a data, right, it has to be wisely used to solve the problem. So it is quite evident that it should be clear to us what is that problem we are going to solve, either for smart city, society, or for us, or for industry. And that is where the first, the data basically are the variables, right, which we collect from the field or asset or a behavior. And then we categorize those data and create models out of it. So the first key is first define the problem. What are you solving? Whether consumption is the demand versus supply, or it could be quality of the problem, quality of the water, or it could be leakage issues. So it could be anything. Once you define key problems you want to solve, the data will get categorized, it will get labeled, and around that we build a model. And this model is purely built based on the real data which comes from the field, because the problem for Bangalore will be different, it could be different for Rajasthan, it could be different for Reliance, it could be different for Apollo Hospital. So the data will get labeled, modeled, and models are built in context of individual consumers or customers, and from there we define the insights. And these insights basically take care of complete life cycle. So for example, you take water, right, which we are talking about. It starts with availability. After availability, you have to design a process to whom you want to give this water, and after design you have to engineer the process, then you have to commission it, and after that, once it is made available, it has to be maintained for years, right? And this whole process uh, has to deal with data, because it is going through a flow of water, and those variables we collect, model it, and use these models using standard algorithms which are available to solve the specific problem. That's how it goes. Maybe
Understood.
Vijay, you can add a bit on top of it. Yeah.
Sure. Yeah. Thanks, Sandeep. Yeah, I guess you covered most of the points there, and particularly maybe I can add a little bit more from water management perspective, because the data, as we start collecting from a data layer, then what are we going to do next? That's the important question that we got to kind of understand now, and that feeds into what is the intended output from the data that is being gathered, right? And there are and multiple things that we can in fact look from a distribution standpoint or the water management standpoint, right? And there are hydraulic models that are extensively used today in the design and simulation of water networks. So you can call it as EPANET and water gems and branch, Jaltantra. There are a number of models that are being used today to develop a water distribution network. And these hydraulic models are well proven; they are all in place. But then you got to make sure that you have these models are fed with adequate data, and then you have the hydraulic understanding the distribution of the pressure and the flow across the system well intact. So that's the first layer of study what you can do with the incoming data. Then once you have the hydraulic pressure balance and everything established, then you feed that into what you call the digital twin with all the adequate additional information that is coming in addition to the data what you are collecting from different sensors. Now, these information could be the records, log records, what the operators maintain, and the geographic information system, and many more things that you can feed into that in order to develop a true model or the virtual representation of the process you want to actually evolve. So that's the next level of details what we can essentially look from the information being gathered.
Understood. So my takeaway from this is, first of all, you have to go from the problem to the solution. It's not probably very helpful to build a killer machine learning algorithm and then look for problems, because as Sandeep said, first comes the use case, and then comes maybe the feasibility and all that. We figured it out. Then we start collecting data. Then we train the models, and then we test the models and validate them, and then we start inferencing from the models, and we start. Then we can start leveraging them into decision making and so on and so forth. So this is my key takeaway, that it has to follow a process, and unless we follow the process, we won't be actually able to see what the final outcome will look like. We have to follow the process, and we have to figure out those use cases, figure out the models to solve for those use cases, who will use those models for what decision making, how to train those models, and then prioritize between them and go through the whole process in a prioritized manner, so that we can create value finally for some key stakeholders. So that's one key takeaway which I have. The other takeaway which I'm getting from Vijay Sai is that actually hydraulic modeling is not a invented in 2020 kind of thing. It's probably something with maybe like 30 years of history behind it or more. And the way I'm understanding it is, you use computers to solve equations of water flow in certain networks, right? And this is the water flow equations themselves, I believe, are more than 100 years old, perhaps, and they've been contextualized to particular cases, maybe which we can talk about, and which can then be solved. So I just want to just raise it with Veena for a second, if I may, Veena. I know you are your work, probably your previous research work, had something to do with these kinds of hydrological and hydraulic models and so on and so forth. And we've had some previous discussions about how industrial use cases and other use cases can present certain opportunities for this kind of modeling. Would you like to say something about the opportunities and limitations of this kind of approach coming from a position of expertise in hydrological modeling for
Sure.
certain use cases? Yeah.
Absolutely. I think we've talked, Hari, in the past about the private use cases where the decision maker is very, very clear. And so linking the model and the model outcomes to actual decisions becomes easier. And this happens very well within what in the water sector we call within the fence applications, which is within an industry, within a hotel, within an apartment complex, right? That's a very straightforward link. We've also talked a little bit more about public decision making contexts where we are sensing up not a one pipe network in one closed complex, but really an entire city, which is what a lot of smart city type endeavors try to do. And there, I think the use cases become much murkier because we've seen, for example, in the case of Bangalore's lakes, where we tried for a long time to see if we could sense up lakes, to see if we could inform citizen groups, for example, where the I would say the pathway between data to decision making or the data to management has many more links to it. And I think in those cases where we're talking about public goods or public decision making, I think there's a lot more work that needs to be done in terms of how is data. And I still think data is extremely important because you can't kind of prevent floods, for example, if you don't have stormwater sensors in your stormwater drains. And we've struggled with in all large cities is that we've developed these massive complicated flood models, but with absolutely no data, very little data.
Correct.
And so some of this is, we need the data, but I think we need stronger use cases for how that data is going to end up getting used.
Okay. Mr. Sushil Kumar, is there anything you'd like to say about the discussion so far?
You have not asked any question.
Well, I was saving the best for last. So I will be asking you some questions regarding how can we leverage.
So I thought, because I am related with the telecom and IoT domain, and you were discussing the hydrological model, so I thought, let me listen to this. In my opinion, the city, this water management system, that should be the integral part of the smart city ecosystem, and the SCADA and other things. The data coming from the smart water meters as well as from the pipes carrying the data, pipes carrying water, that should be connected with the smart city platforms. And the smart city platforms should be able to share the data across verticals. Because suppose some house is logged and the electricity meter is not increasing, and the water meter is showing the meter reading to be increased. So such type of use cases may be developed so that the wastage of water can be reduced. Moreover, you see the NRW figure of India, that is in between 30 to 65%. What I feel, you people may be knowing that Nagpur was working on smart water management from the last 5 years, and they were expected to reduce it to 25%. You see, Singapore is having the NRW figure less than 5%, and USA around 10 to 12%. First, we have to develop the smart water management, and then this smart water management like water metering and GIS mapping of the water pipes, the pressure sensors and other things, so that the water is not wasted. And even the wastewater management has to be developed. And once the data comes into the smart city platforms, then that data can be taken to some digital twin software, and the modeling can be developed there. But our first priority, like as we are developing these smart cities, like the safety and surveillance system and the transportation and other things, in the similar way, we should not develop the smart water management in isolation.
Exactly.
But it should be the integral part of the smart city platforms. Because the cities will face the water problems more as compared to the rural areas. So such type of things are very much necessary. And later stage, as we are going to develop the smart villages also, and all the devices of the smart villages will be connected to the concerned smart city platforms. So in that case, these things can be further extended to the village area also. And once you are having the data and you have deployed the sensors in the pipes and other places, to monitor the water flow, and so that you can check the water leakage, and improve the NRW figures. That will help a lot, and further using this data you can do the modeling. But in my opinion, the transmission of data from the pipes through SCADA, you should have a proper communication technologies. So that suppose the pipe get damaged and water is there is a lot of leakage of water, and you are not able to get the data received in time, so it will be of no use. So first the GIS mapping, and then the proper communication of the alerts and other things should be transmitted to the smart city platforms. And further, once we are having the smart city digital twin, then all the verticals will have the digital twin built in within the smart city digital twin.
Understood,
So,
sir. Understood.
and the platforms which the smart cities are deploying at present, they are proprietary platforms, and they are not based on standards. Even if they cannot share the data across verticals, you have to write
Right.
again and again. So in TEC, we adopted the 1M2M standard, and you see, any of the technology which we deploy, that should have a further roadmap of around 20 years. And if we are having a software platform, then we are using some standards.
Understood.
That should have this roadmap for 10 to 15 years at least, so that in future you need not to replace those platforms. You can upgrade those platforms, and you have to share data across verticals in the uh, and in this way we can improve so many things within the smart city itself.
Understood. Thank you, sir. Thank you for that. I can only call it wisdom, because let me just summarize what my key takeaways from this. The first is, I think, what Veena also said, which is that there shouldn't be like silos formed, and there should be an integrated approach to water, and integrated approach to water twin as well, or water digital twin. Then the second thing which really popped out was, right now what's happening in the smart cities might be happening on these proprietary platforms, which don't have a forward roadmap in terms of shareability and so on and so forth. So would it be correct to say that digital twins should be built on a foundation of open source, for example, so that you can mitigate the concerns of private capture of public infrastructure? Is this something which we should consider? Any comments from the panelists on this?
Maybe a few words. So in terms of platform, I think the complexity comes because these are utility verticals, gas, water, electricity. And for example, each vendor uses its own platform, and then maintainability is an issue for 10 years, 15 years, and then it goes into mess up. So there are common platforms. The recommendation, right, should come from, I would say, regulatory bodies, where they prefer, right, this is the platform, so that all come together and build on top of it. Because nowadays there are multiple common platforms. The effort has to be put by individuals just to build on top of it, and it's
Understood.
I think that is a very good hint for all of
Understood.
purely from maintainability.
Yeah, let me add to it. You see, this like water management is having its own platform, and the gas people are having their own, electricity people they are having own, and it will be create a lot of issues. Then we can have utility verticals within the smart city platform that can have the gas data. It can have water data also, and no doubt some of the from there the data can be utilized by the utility vertical people. Then if you don't use the standard-based platform, suppose you are having one platform today, and after 2 years you are having the intelligent transport system to be built in within the smart city, then you have to either replace the platform, or the vendor will ask a huge amount of money. So this European Union, there was a study in EU, and they were having more than 450 types of platforms. Then European Union has awarded a project to AIUTI, that is the Alliance for Internet of Things Innovation, in Horizon 2020, to carry out the study and find out the solutions, how the data can be shared among these platforms. So the 1M2M, that is the partnership project of Europe, ETSI, that is the standardization body, and these standards have also been adopted by the by ITU. Moreover, when we adopted these standards, then Bureau of Indian Standards, they referred all these standards in their document, that is IoTRA, and they submitted to MOHUA. And MOHUA has referred all these standards in their RFP 2.0 and released in their advisory 19. They should be available on their web page. So, in my opinion, you see the smart city platforms, they should be able to share the data among the verticals as well as between the two adjacent or any two platforms.
Correct.
You see, this water management is one vertical. Suppose another vertical, if you see, like safety and surveillance. Suppose some car is hitting some person and running away from one city to another city, and if you are not able to share the data, then how the camera will be able to of other city will be able to catch that car, and how then in real time how you will be able to share the data with another smart city.
Understood, sir. So what I'm taking away is that a water digital twin or some this kind of software, if it's running, should be linkable to these other verticals, other applications, maybe through some API calls or through some public data exchange, vagera. So, is there something you can say, Mr. Sushil Kumar, about the public data exchange of the smart cities, and can it?
Yes, why not? Why not? You see, like in the smart city platform, devices should be connected with the smart city platform, and from there the data can be shared on through open APIs, and even some data platform has been developed by ISC Bangalore. That may be having the data repository, and further they can share later on, but that platform will not be able to share in real time.
Right.
That is
IUDX.
IUDX. IUDX will work above this sensor-based platform, that is 1M2M and other platforms.
Understood. So the architecture could be like the public data exchange, but you have the digital twins, and you have other stakeholders who are accessing.
Yes.
In this kind of
IUDX will be about the smart city platforms, and then you can have once you are having the platforms, that from there you can take the data to the digital twin.
Understood, sir. So what I'm taking away is that we need to, in order to become de-siloed, we need to leverage the public data exchange which is offered by the public digital infrastructure of IUDX, for example. And we need to factor this into the design principles of the water digital twin. So thank you for
data modeling and other things are very much required. Otherwise, you see, like in the case of tracking device, earlier there were so many manufacturers of the tracking device, and when during Swachh Bharat Mission, let me tell you, this municipal garbage trucks, they were supposed to be tracked, and this project was given by central government to the municipal corporations. Then the tenders were awarded. Then what happened? Every manufacturers were having different data modeling.
Understood.
So then the again the one software is to be written to bring.
Understood. Understood, sir. So that's clearly understood. And what I'd like to now bring the discussion to, since we started talking about the design of the water digital twins, is I'd like to ask Sandeep and Vijay Sai especially, what are the other factors, and Veena, of course, what are the other factors which will go into the design of a water digital twin? In fact, Sandeep, I would just start and say, for the benefit of somebody who's listening and totally new to this thing, what is like a one paragraph explanation of what a digital twin is, just so that they're on the same page?
Yeah, maybe I can just tell a basic definition of digital twin, right? It is virtual replica of real asset, processes, and behavior. Anything on the real-time world. So if you design it in digital technology, it's called as a digital twin. If it comes to water, so again you have to take out the from source to consumer, the whole cycle. Okay. So in terms of, for example, as Veena said, right, there could be a separate availability twin in context of each consumer. The consumer could be city, it could be rural area, it could be anyone. So availability twin defines different variables. It could be groundwater, it could be rainwater, it could be river water. That model has to be built separately. So after source, then it has to go to consumer. And that is where the transit model will come. And that is typically, it could be river flow model, it could be piping model, which is quite standard. And then eventually the basic triggers are the pumping stations, right, which maintains the pressure and direction. So those are the I would say, smaller tweaks within that. And then at the end, at the consumer level, right, how you are using technology. First thing, basic thing is sensing and metering. But for example, you want to build a model for consumer itself. It's a bigger consumer. It could be a, I don't know, municipality itself can build a model for their consumption pattern.
Understood.
Basically, you can build a single model for whole city, or you can bring it into pockets based on the which problem you want to solve. If it is a
Understood.
quality problem, right, it could be a separate model.
Understood.
In nutshell, it is a replica of your physical asset, process, or behavior, which you build virtually to solve the real-time problems. For example, it could be predictive maintenance, it could be risk assessment, it could be future planning, from transitioning from brownfield to greenfield, or mix of
Understood.
it. So
Understood.
it will help you in all aspects: design, planning, then commercial decision making, risk management, predictive maintenance, and also how you effectively maintain it further. So that is in nutshell from my side.
That's a very rich nutshell. So let me just so I'm understanding it as like a virtual software version of something real, like software and sensors version, which allows you to have like a virtual model of some real system. And the thing is, like simulating in real time, ahead of real time. The other thing which really came across in your explanation of digital twin was that it's a life cycle approach, right? So you can actually have digital twins for different parts of the life cycle, different parts of the process. And the third thing which really came across to me was that you have to build them on a specific use case by use case basis. You can't have like one huge digital twin for the whole city, including everything. Probably you'd have to do it bit by bit, like for the pumping stations or for the distribution network, and so on and so forth. So thank you for that. Vijay, is there something you'd like to add to this?
Well, I think Sandeep covered quite a lot of things here. In fact, as you said, the digital twin is a virtual replica of the process. That's the first thing that we know. And the second thing is it works on a real time, or at least on the near real time basis,
Right.
in the water context. So both are very important. And the question that you have now is, what is it in terms of the water digital twin, or what does that mean in terms of
Exactly.
water digital twin? And that's very
Exactly.
important now to
Yeah.
go one step
Yeah.
further down.
Yeah.
And I will add one more part to that, what it means in terms of the country, given India as the country, and what digital twin as a water digital twin means to the country like India. Because when we talk about the developing nations and the country like ours, the situation is slightly different, because we work on an intermittent water supply, which is not a continuous water supply. So the kind of complexity what we see is going to be definitely different, compared to the developed nations. What is that complexity, or what is the challenge that we are essentially facing today, which is essentially manifesting as a non-revenue water?
Right.
And in some of the cities, it is nothing but a loss of water. I pump in X amount of water, but what gets eventually to the end source is only 0.5x. 50% of the water is somewhere getting lost, or it's getting as a non-revenue water finally. So there is a huge losses of water, and then we are trying to tighten up, the whole distribution mechanism here, and we are trying to make more water accountable. But then at the same time, we are facing immense challenges, because this whole intermittent supply might be adding to the lot of anomaly in the pressure, changes. It may be adding a lot of stress to the distribution lines. So then the end user may not be getting the right amount of water with the right quality, what is intended. So this is where the non-revenue water can be handled, and the digital twin can essentially be contributing quite a lot here in terms of guaranteeing the quality, in terms of guaranteeing the quantity, what the end user is supposed to be having. And there will be a lot of accountability also eventually that the digital twin can bring in. People who are little having expertise in this area can easily question this, because there is a district metered, areas what we have marked out now. And there are these areas are capable of, in fact, having this, specific metering capacity toward the lines of 1,500 lines. And then you will be able to have more accountability today with the pressure management system, and you would be able to control the leakages and so on. But the digital twin sits one layer above this now, because it's just not about ensuring the point-to-point delivery, but it's about resource management as well. And which is not essentially taken into account in the regular context, because what is available, what is the demand, if we don't understand this connection very well, then you will not be able to sustain it on a longer time basis. So that is where the digital twin can bring in sustainability in the whole game, by matching the demand versus the resource what you have, and effectively making sure that the demand is met at the required quality as well. The quality aspect is another point which I want to emphasize, but I will wait for the discussion to evolve, because as a country, we are not quality conscious as much as we were supposed to be. There is our whole water resources polluted, and even if when we are talking about the river water distribution and river water consumption, there is a whole lot of emerging contaminants that are coming into the water, which are going into the household applications. People are drinking it today. These are serious concerns, which we are have to face. The disaster going to happen, if we don't control it now. So that is also the aspect which needs to be brought in, and it's not easy to do it, because you don't have an online sensor to measure emerging contaminant today. It has to be done in a lab, and the cost understand the quality aspect. So those are all the points which we have to eventually make into
Understood. No, these are brilliant points, and I think if we're going to do this, we better do it right. My takeaway is that it's floating above the sensor readings. It's not just doing transactional things, but it's enabling, it should enable eventually end-to-end sustainable water resources management. And there are a lot of factors which are not being considered from a purely quantitative view, such as the water quality, which should be factored in. And there are challenges with collecting some of that data, because it might not be possible to automate a lab test very easily, or it might be, I don't know. Or so let me take the conversation to Veena, because we've had some discussions around some of these things. The first thing I'd just like to say is, there is some precedent for these water digital twins in the world. For example, you mentioned flooding is an issue. I was reading a paper about a system called Pipe Dream, which actually is a water digital twin for flood resilience, and for it can actually predict in real time where it's going to flood without having to have a sensor just on every place. So in a smart city, you could send resources there to deflood it, or to redirect traffic, using your traffic lights, so on and so forth. So what are the other use cases? Could you talk about the municipal use case, perhaps with I believe Valencia is a good case study of this, Valencia city, or perhaps the industrial use case, you feel that is what needs to be prioritized among the use cases?
I don't know whether I would say one needs to be prioritized over the other, because there's no reason why these, I mean, firstly, they're not being invested in by the same, by one government or anything. So in a sense, you could have each industry doing it simultaneously. So I would say that I think the industrial use case, as I said before, as well as the apartment use cases, are the easy use cases because they are kind of closed, bounded systems, clear decision maker, clear use of data. And we are seeing, to be fair, a lot of large tech campuses in Bangalore. I've seen both Wipro and Infosys, for example, have very, very good I don't know if you would exactly define them as a digital twin, but they track every drop of water. They have a large dashboard. They know at any given point where their water is. And so I think that's that it already exists. And so it's just a matter of more and more campuses adopting them. And I think as the pressures for accounting increase, that will take care and go on its own without necessarily any government driver necessarily having to drive it. Other than putting pressure for better reporting from the regulatory side.
So can you talk about that, because this BRSR, the business responsibility and sustainability reporting, has changed in India, and there are things like carbon disclosure project which is pressuring companies to disclose. Is that something which you'd like to expand?
So there's a lot of the GRI, for example, also there's a number of sustainability reporting indices that require companies to report, but they don't necessarily require them to have a digital twin. So you could there's no reason why you couldn't have a few meters and a few this thing and kind of come up with a reasonably good paper and pencil version of it and use that for reporting, right? So sustainability reporting does not automatically translate to a digital twin, but large campuses, which are tech campuses, tend to kind of invest in it because why not?
Right. Understood. So what you're saying is that just because data gets published in the open domain because of BRSR or whatever it is, doesn't mean that it won't find its way automatically into a digital twin, or in some way.
And it may not find its way. So it may not find its way into a digital twin. It may not be generated by a digital twin.
Right.
It could be very much old-fashioned paper and pencil.
So Mr. Sushil Kumar, is there something you'd like to say about this? Because the idea with
most of the university campuses they have automatized the water metering, this electricity meters and environmental sensors using the LoRa communication technologies. So they are able to connect around more than 1,000 devices with one small BTS, or you can say the gateway. So in the similar way, this Infosys and might have done, because Infosys is having a very big campus in Bangalore. It's good. They might be having some their own platform for monitoring the water meters as well as the water flow sensors. And I think most of the smart city people, they should learn from the Infosys and the TCS use cases. Because as far as I know, I've attended number of POCs of the smart cities. As far as I know, the smart city management is not the part of the smart city verticals at present.
Right.
I have taken the city surveillance for installing the cameras, the intelligent transport system, or the waste management, just collecting the garbage and other things. But as water is scarcity in the country, especially in the city areas, but before building the water digital twins, it is required at least we should have the GIS mapping of the water pipes. We should have the sensors being installed, water flow meters.
Right.
And even we should have the smart water metering. We are having the technologies, the LoRa or the NB-IoT communication technologies. They work in a good way, and we can have the we are metering the electricity.
Right.
There is no need of charging anybody, or we can say we will charge more. We can make it free, but at least it will give a sense of responsibility that the water is not wasted.
Correct, sir.
That's the main thing. We are having a lot of flood, but we are having a scarcity of drinking water.
Right, right. So thank you, sir, for those points. I'm understanding like one of the critical things is we need other data streams as well, or databases as well, like the GIS map of the waters in the pipes. And we also need to leverage something like LoRa or other kinds of connectivity. So I guess another design principle for a digital twin is, the overall architecture should support like all kinds of connectivity, and it should not just be like wedded to some particular physical layer, so on and so forth. Uh, so I just also want to bring up this case of like how to finance these these things to the digital, to the water network, right? And I just want to bring up the case of Valencia City, which is believed to have the first water digital twin for municipal systems in the world. And I just want to share that they started off installing about 700,000 meters across the city, and that actually allowed them to digitalize and save like 7 million euros a year, which they then invested into R&D, building machine learning models, etc., to predict demand and supply ahead of time, and balance their energy budgets and their quality of service and so on and so forth. So I have the feeling that this is one of those things which, if you implement, will actually pay for itself back much faster than you would expect. So any comments on how to finance a municipal scale digital twin?
Can I just say one comment on the Valencia case? So the Valencia type case is really dependent on 24/7 supply, I think, because the only way you can detect leakage in through metering in a centralized way is if you have a 24/7 system. In most Indian things, and I think Mr. Vijay Sai or Sandeep mentioned this earlier, which is that because we have intermittency, basically your pipe water is deposited into your sump, and then your network itself will not be able to. Most of the leakages that we've seen, and we've done this as a research study, we've kind of done a lot of sensing in sumps to kind of try to understand what these trends look like. So a lot of sumps leak and a lot of overhead tanks leak, but because there's so much of distributed storage at the household level, some of these things you should not immediately look at Western models and assume that they would exactly translate.
Right. So there's Veena like saying, hold on, let's not just copy and paste. Let's look at it in terms of our model of leakage and so on and so forth, and figure it out. So I think what's coming across to me as a key takeaway is that we need to find the right use cases and have like good multi-stakeholder research which says these are the right use cases for us, and we should go ahead with building these kinds of things. So that is my final question. Which
I think number of universities as well as the tech companies like TCS and Infosys, they are already working on water management, electricity management, and others in their campuses.
Right.
So from their studies, the further use cases for the smart cities can be developed, because they are having large campuses, just like one or
Understood.
A small city. Yeah.
Understood, sir. So
And,
I think
I fully agree, Veenaji, that the Western countries' use cases may not be proper to be implemented in India.
Well, that's fantastic insights, and
I think in the water management, at least in the water management, yeah.
The problems of
you see, in India, I think the one of the smart city digital twin, which was expected to be built in Andhra, which was started by Mr. Chandrababu Naidu. Whether that is complete or not,
APWRIMS, yeah.
Any other digital twin of a smart city, whether you may be knowing,
yeah,
in India or not.
Right.
So we cannot think of a smart digital what a smart twin. We are discussing this, but I think let it be carried out in the tech campuses first, and then it can be implemented in the
Understood. Understood. Sushilji says tech campuses and spin-offs of those models are the best way to start. I would just close with this question to the other panelists as well. Do you have any suggestions on, something which is small enough to do but big enough to matter in case of water digital twin? And your inputs, like all the other inputs which you've provided here, will be synthesized into a working paper, advocacy paper of the IET, which will try and see how to apply digital twins to the water challenges of India. So the question is, if you could just wave a wand, like what is the digital twin you think should be implemented? Sushilji has said the tech campuses and spin-offs, but if some of you have other suggestions, those would also be highly appreciated. Okay, so Veena, anything?
I mean, I think cities should aspire to get a little bit more of a grip on floods. I wanted to give another example from Bangalore. The Indian Institute of Science received a fair degree of money from Department of Science and Technology, and they partnered nicely, in my opinion, with the Karnataka State Disaster Management Center to link the real-time sensing of stormwater drains and to flood and to flood forecast, and then feed it into the Varna Mitra app, which then gives you flooding predictions. Now, there are uncertainty bars in each of these links.
The famous error bars, right?
There are error bars and everything. Naturally, these are hard systems because our Indian stormwater drains, again, are not like Western things. There's garbage, construction, people dump debris, crazy things happen over time. But nonetheless, I think that flooding is a case that's worth it only because with climate change, we're going to see increasing as we've seen in the last few years. So it's difficult case, but I think it's worth trying.
Right. So Veenaji's dream app is flood resilience. Okay. Vijay Saibi, do you have something which is your dream app? If you could go for it, in terms of.
Well, I don't know. She covered, quite an interesting application. I would only add one more thing here that when we talk about water digital twin, it's about managing the resources adequately, but we are not talking enough about the wastewater generation and managing the wastewater.
There you go.
Unless you take that and put it into the whole solution, you have not closed the loop. And that is very, very important to manage the wastewater, the STPs, and then make sure that the STP water is
understood.
Reused or recycled in the best possible way.
It goes back to what you were saying about water quality being underappreciated, right? Because the wastewater leaks in, and industrial use of water and their wastewater compromises communities, and without tracking that quantitatively, we won't know how to mitigate for it, and so on and so forth. So fantastic application. And finally, Sandeep, what would your since you are very experienced with digitalization of different kinds of systems and have taken us all along the chain from source to destination, what would your use case of choice be?
I think I will build on top of what Vijay said, right? And then as a society or human, right, we are consuming this water for our existence, okay? And it's not possible for all of us, right, to have a filtered water from Kent, correct? So this water is consumed at multiple places, be it industry, be it hospital, be it a normal guy. The quality model should take care of these variables in society. And then, because that is the final outcome, right? So this quality model should tell us what is the maturity level of India across variables of geographical location or the layers within society.
Right.
What is our base and where we want to reach? So this quality model app will help all of us, taking all the consumers. Yeah.
Fantastic point. And I'm understanding it as you can't just do tech. You also have to have layers of demographics, inclusion and exclusion, access to water, and so many other things like climate resilience as well, perhaps, at every point in the system to figure out how to do the design. So with this, I'll close, and I just want to thank all of you so much, because with the IIT, we've been researching this for some time now, and we'll soon be releasing a paper informed by these comments as well. And we do hope that these kinds of public domain discussions will help us sort of build a design which is suitable for our context and our problems and challenges. And with that, I hand it over, thanking each and every one of you. Please, Suman, please take over, and I look forward to audience questions now.
Yeah, thank you so much, Hari. Wonderful moderation. I think it's a really insightful discussion, and very very engaging one. And
Thank you.
it's hard to put a break to such discussions, because when you're in a flow, you just want to continue it. But there are some interesting questions which have been put forward by some of the delegates here. Starting up with the first one is from Rangaraj MS, who is one of our members and the chair of the Smart Cities Working Group. Any perspective around what should be looked at in choosing a digital twin for water management? This is the question which I'll have on the screen also.
Okay, so we've maybe I'll Suman, should I direct this to some of the panel members, or
yeah, sure. You can.
Is there somebody who'd like to go for this question? I believe we've covered some of it in our discussion, but if anybody would like to comment on this, please go
Just
ahead.
a short and crisp answer, probably.
Yeah. I think then I'm going to choose you. Okay, I'll go one by one. Okay, I choose Sandeep for this one. You just mentioned it. Mentioned so many points that a short and crisp one for this one would be great. Sandeep, you there?
Sorry, am I audible?
Yeah, you're audible.
Yes.
I have muted it. So the perspective, right? What you want to solve, that is the first ranking. Okay. The second thing is, while solving that, are you creating more problems, right? For example, vendor agnostic platform. Are you disturbing gas? Are you disturbing electricity? Putting one line of pipe should not break underground cable, correct? So first thing is, what is that you want to solve? That should be taken into consideration, and it should be a long-term thought process. Vendor agnostic, technology agnostic, and it will solve the problem. I think that should ranking of the problem and how long it will sustain. That should define what you are choosing.
Awesome. That was a great answer. Thank you so much, Sandeep.
Thank you, Sandeep. The next one is from Rupesh. He has multiple questions. The first one is, what is the importance of GIS asset mapping and BIM data in efficient water management? This is the one.
I think we got a direct answer from this, so I'll invite Sushilji to answer this one.
The GIS mapping is quite important. If you don't map the pipes, water pipes being laid, even we should have the GIS mapping of the optical fiber cable, your electricity cables, so that we know where the assets are existing. And tomorrow somebody is digging, trying to lay some other utility services, and then that should not go get damaged. The first thing is this one. And even the government of India is planning to have the separate corridor for this along the highways for the optical fiber cable and the electricity cables. So this was also mentioned during the Gati Shakti event by the Honorable PM. And these things are very important. Even the optical fiber cable which is being laid in the villages, in the Bharat Broadband Network, this NOFAN National Optical Fiber Network Limited, that is having GIS mapping, and water pipes should also have the GIS mapping for the. We are thinking of digitization of everything, and without GIS mapping, how will it be possible? So it's.
I think, yeah. Thank you, sir.
Thank you, sir. So that was a very, I think, keystone point for me, that like different kinds of data streams, not just meter data, needs to go into the water digital twin. So fantastic question.
Before we take the next question, we have a raised hand from one of our members of the Smart Cities Working Group, Ganesh Shankar. Ganesh, I would bring you on the stage. Meanwhile, I'll pick the next question while Ganesh comes and joins us. There he is. Ganesh, can you hear us?
Can I go ahead, Suman?
Yes, Ganesh, please.
Okay. So this is a slightly long question. Hope you guys don't mind. I grew up in the city of Bangalore, which is called as a garden city, and it is also was called as the city of lakes. Probably we had 300 tanks or lakes here, and it's also called as a air-conditioned city. But in my own childhood, when I was a boy of 6, we had a well at home. When I was just joined LKG or first standard, by the time I went to middle school, we got tap connection at home, and by the time I went to high school, the well water went off. That was, I mean, there was no water in the well. By the time I went to college, we also, my father realized that the water is not coming regularly, so you have to have a tank at home. But I mean, a overhead tank. By the time I went to the college, the water pressure was not enough to pump it to my tank, so we had to get a sump at home. I mean, sump, so that the water can cool it. And when I went to my master's at the University of Science, we got another sump, another tank at home. So, and today we also get sometimes even tanker at home. So sometimes I get stuck in traffic because of water tankers than BMTC bus. Just it's a hypothetical question. If I were to have a time machine and I go back and we had a water twin, what problem could have been solved? Where did we go wrong?
Boy, Ganesh, this is like one of those killer questions just coming. So who's going to go for this? Veena, would you like to go for this?
Cities are overpopulated, and cities initially, this water management facility or electricity management facility might have been planned for some number of populations, and now the cities have been overpopulated, and these facilities have not been further replanned and extended. So such type of things may happen.
Understood. So Mr. Sushil Kumar is bringing out the aspect of planning. So I can say based on my reading that water digital twins can aid in master planning, and they can aid in like upgrading these networks, and they can predict demand ahead of time, and they can help you plan for them virtually. So maybe if you interlink a population growth model with migration and so on and so forth with water digital twin, you can start planning for it. If you had like granular data on groundwater depletion at various wards of the city and overlay it with migration there over time, or like population growth over time. So I have the feeling that you need to leverage the water digital twin with other data and other models as well. So Veena, can I ask you something about this? Do you use any modeling for your kind of work, and could you see value if you had a water digital twin to predict or simulate in real time or predictively?
Yeah, I mean, I wanted to say this before also, which is, to quote this phrase, which people say all models are wrong, but some models are useful. I think it's important to realize that the water digital twin, even a water digital twin, which is trying to really mimic this thing, is not mimicking every single drop of water in the city, right? And so I think the point is to therefore say that yes, they can be useful, provided we use them. We firstly don't assume, or we don't over leverage the digital twin, in the sense you understand what the digital twin is built for and you're able to use it for that. Now, that being said, your basic question was, could we have planned better if we had better models and better data many years ago? And I would say yes. I think Mr. Sushil Kumar also said that planning is always useful. The only other piece I would add to that is financing as well, because I think that some of the problems with some of these things is not being able to, because we're not able to predict well and predict accurately, we're also not able to make things financeable. And therefore you're not able to then to bring in money into the system fast enough. And I think Mrs. Sushil Kumar said, cities are growing so fast. The big problem is we're not able to build the infrastructure fast enough. So the speed component of how quickly are you able to mobilize ends up becoming the challenge. And if that digital twins and the models associated with them, some of the models of the kinds that we've built, which involve all the pipe network, stormwater network, groundwater, and wastewater integrated in some way. But if you're able to do that, then you can there's so much more nimble that you can be as a city grows. So, yeah, just trying to be hopeful here.
No, I mean,
I would like to add, Veena, this. We have to digitally transform all the verticals, including the water, wastewater, and even the electricity and everything, starting from the metering to the leakage. And if we digitize all the things, then even we shall get the data on the smart city platforms, and after that we can build up the digital.
Right. So, Vijay Saibi, please.
Yeah. So I'll just add, because it's a very philosophical question what you brought now, and there is no direct answer to that. Because if the purpose of the water twin is to manage the resources effectively and to get the water at the required quality and quantity, I cannot use it to basically say how the resource depletion is happening and how that can be basically supplemented, and then what should be done, to keeping this in 10 years ahead down the line, how this can be handled. Purpose is very important, and we got to, have the right purpose to solve the problem. In this case, I think, as Sushil Kumar sir said, we probably have to steer it in a different way, and then bring all the verticals together to understand population growth, the drought, the drop in rainfall, the groundwater depletion. Everything has to be combined in order to predict the outcome what you are suggesting now.
Thank you, Vijay Sai, for that point. I would just also juxtapose it with the previous point that we have to go use case by use case. And since these are models, we can learn from the models, right? So even if they're only useful and not completely correct, as Veena ji said, we can still learn something from them and factor it into planning is how I would be as optimistic as possible. Sandeep, anything you would like to add on this point of planning and leveraging digital twins as models for that?
Yeah, the last point, right? The accuracy of the model, correct? So that totally depends on how many variables you are taking into consideration.
Right.
With water has to always come from the ground. If that is the single variable, then your hardness will increase, the depth will go down, and you are depending on the same. And then your accuracy will get impacted accordingly. So for example, if I have to predict for next 20 years, am I taking care of all possible variables when I am building my model? Okay, and some variables evolve in a process. Maybe 5 years down the line, you will find 10 more variables, and your model will take a different direction. Current accuracy is 60%, 70%. It will evolve, and that will evolve based on quality of data and what variables you are considering. So, for example, 20 years before, groundwater or river water is the variable. Now it could be even recycled water, or it could be lake available, and so on.
Understood.
The accuracy evolves over a period, and you have to take care of all possible n number of variables. Again, I'm saying possible because they will evolve. Okay.
Correct. So these would be what I believe in policy planning is called like different scenarios, right? And we'd say, if it's just business as usual, or if we start reusing wastewater, or if we implement rainwater harvesting at a big scale. And I'm seeing, I'm sure Mr. Sushil Kumar could tell us a lot about policy planning using modeling. And the question I'd just like to leave us with is, how can we leverage digital twins and database decision making for this policy planning as well?
Thanks. So Ganesh, does that?
I want to make a final comment on that. Can I?
Yeah, please.
Yeah.
So if we go in this direction, my son probably would be consuming water through capsule. But I would say if we come up with a vision to reverse the trend, whether we use digital twin or whatever, right? And ensure my son would have a daughter or son or whatever. He would actually tell the story in a reverse way. Like, I used to consume water in tankers, and then we had a tap again, and we removed the sound, and finally he says we have water in the well.
Ganesh, it's a really fantastic question, and the fact that it has silenced everybody means that it's like one of those research questions which needs proper thinking and evidence based analysis. Uh, so what I'd say is, like, let's work on it through our further activities at the IET, because the IET is applying engineering and technology in order to address exactly these kinds of questions. And for me, the value.
What I want to add, Hari, is that I think we should also have a thinking of digital till is not the solution. Start from there, and then start thinking whether really digital twin is a solution. I know I'm writing this paper with you, or probably leading the paper.
No, this was a point which came up multiple times in the discussion.
Correct. Yes, yes.
We should start Sandeep's point, in fact, right at the beginning. And it was.
Yeah, and Hari, I just want to add, he is absolutely right. Let's look at Singapore as a country which is resource constrained, and then they have managed the resources so well. Now they are bringing digital twin on top of it to improve the effectiveness.
Right,
And that is how the evolution has to happen. It cannot be the other way. That the digital twin can solve your fundamental issue.
Right. Awesome. So I think we should close the discussion here because
we have one more person, Hari, who has raised a hand.
Please.
I'll quickly bring him and take the last question from him, or see what he has to say before we close it.
Sure.
Ganesh, I'll keep you here since you've come in. I'll not leave you now.
Hello.
Hello, Mr. Hege, can you hear us?
Yeah, yeah. I'm able to. Audible to you?
Yes, you are.
Yeah, I had a couple of experiences in Bangalore. Last 35 years, I've been in Bangalore, and then we never in Bangalore. But 4 or 5 years back, I had been assigned a task of flood and then storm diversion in a multiple complex which was coming up. When I was doing a complete detailed study analysis, I found that our planning has not considered terrain models, the construction activities, and the natural systems, drainages, and hydrological models. That's what I found out. And then also, planning has not taken into perspective analysis of the very frequent rainfall intensity pattern. Till 2010, Bangalore never had more than 70 per hour intensity of rainfall. But now I have been collecting data and analyzing it. Now, last year it was 140 per hour intensity also we have received. It all means to say that city is growing and we have good maps for tracking and then all our, what we say, transportation communication. But it needs to have very critically developed or integrated into digital twin model. Means basically spatial mapping, accurate planning with terrain models, hydrological analysis, and then intensity of rainfall, and then more than everything else is sewerage network. It is during the floods the sewerage networks get burst, and that causes more than 60% of the floods in our Bangalore city.
Thank you for the point, sir. It's very well taken. I believe Veena's dream app is also the flood resilience, and this 70 to 140, if I'm not mistaken, has something to do with climate change, because the variability goes up and the intensity of rainfall goes up, even though the overall rainfall might go down. That has huge implications, I believe, because it doesn't have enough time to filter into the groundwater tables, and it has those kinds of impacts as well. Would anybody else from the panel like to share their comments on this very insightful remarks from Mr. Hegde?
Good.
Okay.
So Mr. Hegde, I'll leave you back to the audience now, and
Thank you.
we'll summarize the session. Thank you for coming here, sir.
Yeah.
Thank you.
Hari, if you would like to summarize the entire session in one piece, I know it's a tough job to do, but since you've been so good at it.
Yeah, I mean, the summary is, we need to figure out what problems we need to solve, and how to design specific water-related digital twins in order to solve those, respecting certain design criteria such as interoperability, and other things, integration of different data sources, breaking down the silos between different agencies and institutions, and so that we have better sustainability outcomes across the city. So this is what I'm seeing, and if it's sounding fuzzy and vague, it's because it's I think it should be a long-term goal to figure out how to do that, and I look forward to doing this with the IIT. If you'd like to learn more about this approach, and with a lot of reading and references as well built in, please wait for our advocacy white paper to be released, which will contain a lot of details factoring in everything which was discussed today. So that's what I'd say.
Thank you, Hari. Wonderful. And yes, it is certainly something to look forward to, that white paper, and we'll obviously notify everyone, and we'll have a copy of it, sent to everyone, and we'll also have it on our website for people to come and view it. And with that, I would like to thank you, Sandeep, Veena, Vijay, and Sushilji for coming and sharing your brilliant thoughts and insights with us, and giving us this time towards the end of the year to close the year on a high. I think it was a very, very important and interesting discussion today. And to all the audience,
from my side as well, to the speakers and to the audience, please, thank you so much. Thank you so much for being here.
Yes. And a big thank you to the audience, for taking the time and hearing us and asking these questions. And there are a few still which are left, which we could not take up due to the amount of time, but we can always discuss these things and come back to you with the kind of answers that you seek. With that, I would say it's a wrap for the year from all of us at the IIT, and we wish you a Merry Christmas and a super duper Happy New Year. And I'll see you again in the new year with some new stories and new trends and technologies with the real conversations that will continue. And we have a lot to look forward to. And I hope that everyone is safe, and we keep doing good.
Awesome.
And keeping well. Thank you so much.
Thank you so much, everyone.
Thank you.
Bye-bye.
Thanks.
Bye.
Bye.